Good morning, students. Welcome back to YouTube channel SchoolQuizz.com. As you know, my name is Danish Agarwal. As we have started our chapter number 2, is matter around us pure. Is matter around us pure, in which we have covered a lot of topics and a lot of NCERT questions of chapter number 2. And today we will discuss separation of gases from air. Separation of gases from air. So let's start. That is chapter number 2. Is matter around us pure? Chapter number 2 is matter around us pure. Is matter around us pure, in which today we will discuss, that is separation of gases, separation of different gases from air. Separation of different gases from air. As we know, like air is a mixture of gases. Air is a mixture of gases in which several gases are present. Like as we know that like most of the gas present in atmosphere is nitrogen, like 78%. Like oxygen gas, which is very also in very huge amount, like 20.9%. Like argon gases are present, like water vapors, dust particles are present. So we have to separate gases from air. So how we separate it? We will separate it on the basis of their difference in boiling point. We will separate it on the basis of their difference in boiling point. And we have already discussed what is fractional distillation. In this case, we will use our technique, that is fractional distillation. Because in fractional distillation, we have discussed what is fractional distillation. We will use that technique. We will use that technique when the boiling point difference is less than 25 degree Celsius. That's why we will use here our technique, that is fractional distillation. And main concept is that when there is difference in boiling point, due to which they get separated out according to their boiling point. Like if we want like separate water vapors, we will use sulfuric acid. As we know, sulfuric acid is a dehydrating agent. It will absorb all the water. Vapors from the air. So we will discuss this topic very deeply, in detail, totally. So be patient and watch the full video. So let's start. First of all, if we see, like we will use here 2 points major. First one is the constituent gases in air. The constituent gases in air. The constituent gases in air can be separated. The constituent gases in air can be separated from air. Can be separated from air by fractional distillation. As I have already told you, when we use fractional distillation, when the boiling point difference is less than 25 degree Celsius. When the boiling point difference between the gases or between the constituents is less than 25 degree Celsius. Second one we will use, that is we can write it as in the fractional distillation of liquefied air. In the fractional distillation of liquefied air, that we have to liquefy the air. So how we will liquefy the air? Like we will put pressure. Suppose in this container there is a molecule of gases. Like if we want to liquefy that, what we can do? We can increase its pressure. For example, like their gases are present. Then molecules of gases are present. Suppose pressure is like on this way. Okay, so here gases molecules are present. Suppose if we push the pressure, and we will get it on here. We will put the pressure, and here till here we will put the pressure, and what will happen? The molecules will come here. Like then we can liquefy the air. What will we do? We will apply the pressure We will apply the pressure due to which space decreases and the molecules come closer. So as we know that it will be liquefied. For example, like if we say this is a block in which solid particles are there. Solid particles are totally packed. Solid particles are totally packed. Or if we talk about liquids, that there are some spaces. Suppose if we talk about gases, like more spaces there. So if we apply pressure, then suppose here molecules will come closer, and then they will get liquefied. Okay. And one thing is, like in the fractional distillation of liquefied air, we can do it with the help of two methods. That is decreasing the temperature, or increasing the pressure. Like how we can liquefy the air by increasing pressure, we have discussed that we will put pressure and space will be less and the molecules will come closer and it will turn into liquefaction. So if we case like decreasing the temperature, as we know, if we decrease the temperature, the kinetic energy of the molecule decreases. That's why they also come closer. So with the help of like decreasing the temperature, we can also liquefy the gas. With two methods, we can liquefy the gas. First one is increasing the pressure, and second one is decreasing the temperature. How? By decreasing the temperature, kinetic energy of the molecule decreases, due to which they come closer and they can get liquefied. But in case of pressure, like when we put the pressure on that, the space will decrease, the molecules will come closer and they will get liquefied. So you have to remember that with the help of what we can liquefy air with two methods. First one is decreasing the temperature or increasing the pressure. So we will move further. That is, in the fractional distillation of liquefied air, the gas which has the least boiling point, as I have already told you that separation will occur on the basis of their difference in boiling point. So in fractional distillation of liquefied air, the gas which has the least boiling point distills first. The least point distills first, while the gas with maximum boiling point boiling point distills at the end. Now we will draw a table in which like their boiling point is given. For example, like we will say, here is our constituent. It is our constituent. Here is oxygen gas, that is O2. Here is our argon gas, that is AR. As it is a noble gas, that's why it's only one atom will be there. So it is stable like only one atom, and it is argon. Next one is our nitrogen gas, N2. If we talk about constituents, we will write like first one is boiling point. In case of degree Celsius. It is like minus 183. It is minus 186. minus 196. That is 196. Percentage by volume in air. Percentage by volume in air. So it is 20.9. 20.9. This one is 0.9. And that one is 78.1. 78.1. So as you see here, that is there is difference in boiling point. There is difference in boiling point. Like oxygen boiling point is minus 183 degrees Celsius, argon is minus 186 degrees Celsius, and nitrogen gas is minus 196 degrees Celsius. As we have written here, that is in the fractional distillation of liquefied air, the gas which has the least boiling point, distills first. For example, if we talk like these three gases, oxygen, argon and nitrogen, which will distill first, whose boiling point is minimum. So nitrogen will distill first. Second, then argon will distill at second position and oxygen will distill at third position. As we know, the boiling point of nitrogen is minimum in case of these three, that is minus 196 degrees Celsius, argon minus 186 degrees Celsius, and oxygen is minus 183 degrees Celsius. So which will distill first? Nitrogen, and then argon, and then oxygen. In this way they get separate out. We will draw a flow chart of this. Like in short. So it will be like the separation of different gases from air is shown with the help of a flow sheet diagram. So what will we do here? First of all, air will be there. This will be our air. And we know air is a mixture of several gases like free from CO2 and water vapors. We will see that how CO2 and water vapors get separate out. Like water vapor, we will use sulfuric acid, as it is a dehydrating agent. It will absorb all the water. We will discuss later. Like free from CO2 and water vapors. Then what we will do? We will liquefy the air. Liquefied air. So two methods I told you how we can liquefy air: by increasing pressure, or by decreasing temperature. Or we can write it as by increasing. We will write it like increasing pressure and decreasing temperature. Then after liquefied air, that is what will we use? We will use fractional distillation. Fractional distillation. And then what will happen? They will separate out on the basis of their boiling point. Then here will be our nitrogen, that is N2, and here will be our argon, and then here will be our oxygen, as it has least boiling point, and it has maximum boiling point. So you have to just write in words. With the help of flow chart, that you can, if you like, draw this flowchart in paper, that it will also show a better impression that you have the knowledge. First of all, what will we do? We have air, we will free it from carbon dioxide and water vapors, and then what will we do? We will liquefy it. We will liquefy it with the help of increasing pressure or decreasing temperature. Then when the air gets liquefied, what will we use? We will use fractional distillation. As fractional distillation is the technique which is used to separate the mixture which has boiling point less than 25 degrees Celsius. Then what will happen? They will separate out nitrogen, argon and oxygen. Nitrogen will have reached boiling point, argon as it is, and then oxygen maximum boiling point. So argon oxygen maximum boiling point. So we will write all in words. We will write also all in words. Like anyone has to write in words, so you can write it also in words. So we will start here. We will write all the lines, that is air is a homogeneous mixture of, like you have to see, like air is a homogeneous mixture, and we have already discussed that air is a homogeneous mixture. Why air is a homogeneous mixture? We have already discussed. So main points we have to highlight that air is a homogeneous mixture of a number of gases. As we know, nitrogen has maximum nitrogen, that is 78% by volume. 78% by volume. Oxygen 20.9% by volume. Are main constituents. Apart from this, that air will also contain CO2, that is carbon dioxide. Like as we know, water vapors are there, carbon dioxide, water vapors. Air will also contain carbon dioxide, water vapors and inert gases. As we know, what are inert gases? Which react very less. Like what are inert gases? Helium, neon, argon, krypton, xenon. Out of which argon's percentage is maximum. So we will write air will also contain carbon dioxide, water vapors and inert gases, out of which argon, that is AR, is main constituent. Out of which argon is main constituent, that is 0.9% by volume. 0.9% by volume. So in order to separate the different gases, air free from dust particles, we will use like air which is free from dust particles. Air free from dust particles is first passed through caustic soda. Caustic soda solution. Like some students are curious to know that is what is caustic soda. Caustic soda is nothing, it is NaOH. which is a base as well as alkali. Okay? Through like first pass through caustic soda solution, which absorbs CO2. Like CO2 gets separated, which absorbs CO2 and then concentrated sulfuric acid, and then concentrated sulfuric acid. As I have told you that sulfuric acid is a dehydrating agent, that it will absorb all the water. It absorbs all the water vapors, and then concentrated sulfuric acid absorbs what? That is absorbs water vapor. Absorbs water vapor. Absorbs water vapor. As we have saw in our flow chart, that first of all air gets separated from water vapors and CO2, and then what will we do? We will liquefy the air. So we will write also, that is after then now we will liquefy the air by increasing pressure. We will liquefy the air by increasing pressure and decreasing the temperature. Next, what will we do? The liquefied air is then allowed to distill. The liquefied air is then allowed to distill fractionally, like fractional distillation. Distill fractionally means fractional distillation. Allowed when the component with least boiling point, that is nitrogen gas, nitrogen so gets distilled first, and oxygen will distill at last. As it has maximum boiling point out of three gases, nitrogen, argon and oxygen. Out of these three gases, so first of all N2 will separate first, and then argon at second, and oxygen at third. So this is all about our today's topic, that is separation of gases from air, in which we have discussed first of all what we do. We have air, which is a mixture of gases, like several gases are there, CO2, water vapors are there, nitrogen gas, oxygen gas, argon gas is there. So what will we do? First of all, we apply caustic soda. It will absorb all CO2. And then what? Then we will apply dilute sulfuric acid, concentrated sulfuric acid. What will it do? It will absorb all the water. And then what will we do? We will liquefy the air. How will we liquefy the air? We will liquefy with the help of applying pressure or decreasing the temperature. And after doing that, what will we do? We will apply our method of fractional distillation. Fractional distillation, as three gases which are left mostly like nitrogen, oxygen and argon, there is difference in their boiling point which will help us to separate out. Like nitrogen has least boiling point, it will separate first, like then an argon, and at last oxygen will separate out. Oxygen will separate out. So this is all about our today's topic, that is separation of different gases from air. Separation of different gases from air. We have discussed this topic in detail. I hope that it is clear to you. If you have still any doubt in that topic, you can comment in the comment box section, or you can also sign up to our site, that is SchoolQuizz, and you can get videos also of like class 7 to 10th all. Like if you have any doubts till now, you can comment in the comment box section and I will remove that query. So I hope that this is clear to you. So this is all about today's topic. So thank you students, thank you very much.